Welcome to the radio room. We're back. Going to be looking at the Hewlett-Packard 204C power supply project we've been working on. This is part two. In the last video, we kind of went over a design for a power supply that we were going to modify into the oscillator. Things changed after I started looking and taking things apart. The transformer on that power supply, they got it right in the schematic. I was looking at it wrong, I suppose. I did look a little closer. That center tap is not a center tap. It's actually part of the 230 and 115 volt switching. How I got 20 volts off of both of them, I double checked it even last night, and it still shows as a center tap and 20 volts on each side, but we're not going to go with that. So we're going to kind of scratch part of that idea. I think what we're going to do is we're going to build ourselves an external power supply to hook up to the oscillator that'll have both the positive and the negative 13 volts and the 0 volt reference. But we're going to do this in, well, we're not going to just use all new parts. We're going to scavenge a little bit. We're going to scrounge a little bit. A lot of people, when they work on electronics, have a lot of parts stuff laying around. And sometimes the funnest thing to build is not something that necessarily came straight out of a package and you put together. We're going to look around. We're going to find some stuff that we can use to build this power supply out of and have a little fun doing it. So let's get started. So here's the power supply that we were looking at yesterday. The factory power supply for the HP 204C. I went ahead and made it so we can get the board off of the backing plate. That's just the plugs, a couple standoffs, the plugs, the switches. We'll still need that because we definitely want to have a back on our HP oscillator, and we still are going to need to mount this on there, even though basically everything on here is going bye-bye. So we're probably going to strip this down. We still want to keep this connector, and we'll find a good spot to tie our power into to make sure we have it on the right pins, our positive, our negative, and our ground. But pretty much everything on here is coming off. We'll just make us a new power supply out of some old stuff, a little bit of new stuff. Let's go ahead and look at how we're going to do this as far as the schematic. This is what we looked at yesterday. This is the positive regulation portion of the power supply. We're still going to keep this. This is going to change very little. This is actually the negative one since I got the 337 listed on there. But like I said in the previous video, the positive and the negative are both pretty much the same circuit, just using a different regulator on the negative side than the positive side. So this is pretty much going to stay the same. Now we did have this yesterday in our last video. This is was showing an example of how we are going to have our transformer, and we needed the center tap for the ground. We're still going to do that. The only thing that's going to change on this is, in order to make sure we have proper filtering, because we're not going to use this capacitor anymore. We're still going to have our negative rail going through there. What we'll probably do is, in order to get this filtered better, because like I had mentioned before, once we rectify the AC, it's got a lot of ripple to it. We're probably just going to add a capacitor here and here to take the place of the one that we had here. And that might go either way. We might do it as two like that. Depending on what I can find, we could just go with the one as well. But I do believe this will give better filtering for each half of it if we do use two individual electrolytic capacitors right there. So we'll take a look at that. But we've got to make sure we have the right parts. This, as it turns out, and I'll show you why, I originally thought that this center pin here was a center tap. Well, after I took this off and looked at it, this right here is the center tap. I followed that trace over and it goes over to the rectifier bridge. I'm sitting there scratching my head going, why in the world would a center tap go to one side of the rectifier bridge? Well, that's probably because it doesn't. That's not a center tap. There's 6 pins on this transformer, and I finally got to looking a little closer at the schematic. Actually, I had to blow it up on the computer because this is just hard to look at, pretty hard to see, but I think I can still show it to you. And I should have paid attention to this yesterday, so just make sure, you know, if you're taking stuff apart and going to redesign stuff, look at the circuit itself. There's something you might have missed on the schematic, and that's kind of what we did the other day. There's no center tap on here because there isn't a center tap. What I failed to notice was what I thought was 2 pins for primary or have 3 pins on the in the primary side and 3 pins on the secondary side. There's actually 4 pins on the primary side and 2 on the secondary side. The reason for that being, you can see right here, this is the switching between the 115 and 230 volts. Those other 2 taps on the primary side are where it connects either these 2 in series or uses these as 2 individual windings on the primary side, depending on where this switch is. So 4 of them are needed just on the primary side, which only leaves 2 on the secondary. There's no extra pin to have a center tap. So, as I mentioned before, they're creating their 0-point reference voltage using the batteries. We still have the same problem, so we can't use this transformer to make our positive 13 volt and negative 13 volt in relation to the ground plane with this transformer. It's not going to work. There is a way to do it, but you have to make sure that both positive and negative have the same current on each side. Otherwise, you'll actually end up getting DC trying to flow back through into the transformer. You'll have we're not going to go into that right now. So this isn't going to work. Basically, everything on here is not going to work for our new transformer or our new power supply. So I looked through, and I do not have any rather small center tapped, appropriate voltage transformers. So I was like, well, let's start looking through the old junk box, as I think my wife probably thinks it's probably the junk room. Lots of old stuff around that I try to get parts out of and everything, and trust me, you never need it until you throw it away. Fortunately, I haven't thrown it away yet. So I found a couple of actually old power supplies that we're going to get some parts out of. Here's one. And then this is out of an old computer power supply. It's an old, I've already pulled the board out. There's our transformer. That's the transformer we're going to use. And we do have a bridge rectifier in here. This is set up, it's a 4 to 6 amp regulated power supply. It died a long time ago. It's probably fixable. But I have bigger power supplies. This is 4 to 6 amp. It'll power some stuff, but it doesn't power a lot of what I have. I like to have 20 to 30 amp power supplies, especially running communications equipment, running tests on the test bench and stuff. It's not big enough to necessarily do what I want. If I'm testing a 100-watt transceiver, this just isn't going to handle it. So I'd rather just have one power supply on the bench. I have a 20 amp Astron that I use on the bench. And this one died. It let out a loud growl several years ago. Nice 60 hertz growl, and died. And at the time, it was a rectifier diode that had failed and shorted out and popped the fuse. And it was a good power supply for a while I had it. And I could probably go in here. I'm sure it's just something in the regulator circuit has died, because it just won't put any voltage out. So maybe a Zener diode went down or something, and it's not regulating right. But it's been sitting in a box for a while, not doing anything else with it. The case is a nice case. It's been repainted. So we're going to use this transformer. We'll probably use this bridge rectifier. Right now it's set up in just positive voltage only. I mean, it's just a 12 volt or 13.8 volt power supply. So we'll probably get this board out of here. We'll strip some other stuff out of this case. We'll probably use this case as the new power supply. Get a cord coming out or something. Figure out a way to get some power into here and tie it back into our board, so we can still use this right here. I'm pretty much going to clean this board off. There won't be hardly anything left on it. So we can probably tie in wherever we need to pretty easily. So this is going to be our case, our transformer. I have already checked this transformer. And as you can see here, it does have a center tap. I verified that. We actually have 25 volts on each side. It's probably closer to 26 or 27. I measured on the after the rectifier. So you're gonna drop about a volt on the rectifier. So we have good there. We have sufficient voltage. This was doing 4 to 6 amps. It's gonna do 100 milliamps, no problem. So we'll probably just take this board out. We'll have to figure out how to get some stuff out of there. Well, I wonder if that's the reason why it doesn't work, and that might just need to be resoldered. We'll see about that here in a minute. It might have a perfectly good power supply I'm about to tear up, but you know what? Even if it works, we're probably still going to do it. So we'll probably use this as the case. Maybe take some stuff out of it. We'll try to make it look good, but sometimes it's fun to just take old stuff and make it work for something else. On our schematic, and like I mentioned, this has 25 volts on either side of the center tap coming out of that rectifier. These filtering capacitors here have got to be able to handle at least 25 volts on each one. If we go across from the positive to the negative, like the original capacitor was, we would have to be able to handle a minimum of 50 volts across there. So I was looking around and I'm trying to find some filter capacitors. Most of the kit of filter capacitors or capacitors that I got, electrolytics, didn't have anything that was sufficient capacitance, and the highest voltage rating was 50 volts. Well, that's really pushing it. And you try not to run a capacitor right at its maximum working voltage. Give yourself a little headroom so it doesn't work the capacitors hard trying to hold back that amount of voltage. So that's where this comes in. The old computer power supply. I'm not even sure if this thing works anymore. But what I did find is these two right here. These are 4700 microfarad or 4.7 millifarad, but they're rated at 200 volts. These things are not even are just gonna sit here and laugh at the voltage we're throwing at them. Even if we put it straight across between the positive and the negative rails, it'd still be only at a quarter of the rated voltage. So we're gonna get that out of there. We'll probably use them like I had on the diagram there. Not sure there's much else we're going to use off of this. Everything else in the circuit after that is pretty much what we had on that other circuit. So we'll use those parts that I've already obtained. We'll use a brand new 317T and a brand new 337T. So why don't we see if we can't. First off, I'm going to solder this thing back in here. And we're just going to see if the power supply works, man. Because I wonder if that's the whole reason it didn't want to work. Maybe the last time I was working on it, that just wasn't soldered good and I didn't notice it. So I'm going to see if I can. This is out of curiosity's sake. We're going to use this thing whether it works or not. So we'll just see if we can't solder that back on there. Make sure it's not touching the case. It's not. If this thing works, I'm going to laugh. I worked on this thing, worked on this thing, and if it's a wire that's right out there in view, I'm going to laugh. Plug this thing in. Oh, it's right up, knocking the camera around there. Get our volt meter ready here. Well, it didn't blow up. Nope, it still doesn't work. I don't have the voltmeter in a spot where you can see it right now, but that was not the problem. It is probably on the regulator board here, but that's beside the point. It's about to not be a regulated 12 volt power supply anyhow. Get this unplugged. See if let that capacitor in there drain off a little bit. It's got a 25 volt 4700 in there as its main filtering capacitor right off the regulator. Well, they're really pushing the limit on that. I was measuring this at 25 volts on the positive side there. I'm going to actually show you this. So turn it on, and I'm going to show you what voltage each side's running on this. So that's running 26.7 volts. It's not loaded down real hard. But, yeah, 26.7 volts across a 25 volt capacity capacitor. That's probably hard. We're running that capacitor pretty hard. So let's just, we know it's got 26 volts coming out on the on that side of it. See if I can get a should get something like 25 there as well, but it's still over 13, so we can regulate it. It might be because of the loading on the circuit that it's bunking that side up a little bit. Let's go to HC here. Okay, from one side of the transformer to center tap, 19 volts. From the other side of the transformer to center, 19 volts. So actually, this is going to work out pretty good. This is going to be just about the same as the voltage we had before on our old schematic. I was saying 20 volts on each side. That one, this one's just a little bit less. So this one's going to work just about the same as the other one. I was concerned if we get too high a voltage, we're going to be dropping too much through those regulators and making a lot of heat. But we can heat sink them in these things pretty good. Probably mount them back here. We might even reuse the original holes they used to mount them to. And that whole back plate of the case, which has a pretty good heat sink on it, being held on by those screws. Yeah, we're going to have plenty of heat dissipation on that. So So let me get this unplugged. We'll see if we can't get this board out of here. And see if we can't strip some stuff out that we want to get rid of. So I am going to unhook the transformer from this board. So I just need to pull the bridge rectifier off, get the center tap off, no, it tried. Ah, there we go. Had a little curve to the wire there. That's what was hooking it on there. Let's straighten this out a little bit so we can work with it a little bit easier later. Right like that. So, of course, here's our output going over to here, and also feeds that cigarette lighter. We'll go ahead and undo those from there as well. Leave my soldering iron off a little bit. I'm going to get the voltmeter out of our way real quick. Get it back up on its holder. So we can't pull these out of here. This is going to be quite a bit of heat needed for that. Trying to get in there and get some good contact. There we go. Get this one off of here. That one was pretty easy. Ooh! Flung some hot solder on my wrist. That did not feel good. So, and we'll go ahead and unsolder the pass transistor on the back. This one might be wrapped. Alright, so let's cut that board out of there. You know what, when we redo this thing's probably not going to just be floating out here. I'm going to go ahead and undo the bridge rectifier from the transformer as well. Kind of let us see where we're going in here. Big old blob of solder. Alright. I'm thinking this puppy needs to come out of here. It's probably going to be a little bit easier said than done. Get this cigarette lighter deal out of here and give us some room inside. Wow, it clips like 4 different directions here. I'm gonna get my finger down in there. Get some tools on here. And there we go. Well, we're gonna have a big hole in the front. I'll find something to close that with. We're not gonna need that in there. We'll take these binding posts off the front as well. Let's see. Let's don't come loose goop in here. Looks like a wrench. Would be our best bet. Let's see. Oh, big. Just right. Alright, we'll get this one out here in just a second. This one out of here. And we'll hold on to these, you never know. I need them somewhere else. They're still good binding posts. And get the nut back on here. And we'll save those for later. Still need the power switch. It's still in good shape. There's the fuse. I'm going to leave that on there for right now. It's holding that heatsink in place. Maybe some usable parts on there as well. Set it off to the side. Gonna need this. Probably reuse it. Bridge rectifier. So we'll set this off to the side in our parts. Let me go ahead and get this out of the way, and we'll see if we can't get those capacitors off of the computer power supply. They look like they ought to be fun. They got goop stuff on there to hold them in place, so we're going to try and get the solder off of there first. See how well this works. Got nearly all of it. One little spot that's being a little cantankerous. Might actually use some solder wick on that, see if I can't get it to wick out of there. Can't suck it out of there. That's a little better. Didn't do too bad. See if I got one little spot here that's kind of holding on. I'm going to see if I can just flex this over. It's pretty solid. Like I said, it's got some scoop holding it on there anyhow, so hoping it'll, if we can get it unsoldered good, it should just come right out of there. Might have to try and walk it just a little bit. Got one side loose. Yep, we just got good hold it now. Let's see if we can't get some of this goop to let go. Looks to be in fairly decent shape. Let's use the capacitor measuring meter here and make sure it reads pretty close to what it's supposed to be. Oh, 470 microfarad. Oh, it'll still work. And it's reading 466, so that one's still reading in tolerance. Put this over in the stack of parts we're going to use. If we can't get that other one out. More goop. 470 on that one as well. And 460. I think that one's still good too. Stick it over there. Don't think there's anything else we're going to use off of here. Thought about getting this fuse off of here, but the original power supply had a fuse in it, so we'll just keep using it. A rectifier diode set right there. It's a switching power supply. Actually rectifies it from AC to DC before it even steps the voltage down. Actually, the voltage actually comes up some before it's brought down to service levels. Oh. That is most of the parts we're going to use. I'll show you. We got the two capacitors we're going to put in there. Bridge rectifier. This is going to be our case transformer we're going to use. Center tap transformer. And we'll build a circuit into this to regulate it to 13 volts out. And we'll see how we want to get power out of this box. Really like to get it out of the back. Maybe just plug some holes here. Heck, I might just repaint the front end so you don't see that. Just maybe leave a regulated power supply on there. But that's where we're at right now. I'll show you the schematic. That's the one we're going to use for voltage regulation, and that's actually going to be pretty accurate right there. It's going to be 19 volts or so, maybe down to 18. Still going to give us enough headroom to maintain our 13 volt regulation, especially with the low current that we're going to be pulling off of this. And of course, that's the other half of our complete diagram, more like a block diagram than anything. This right here is this. Got that. We're going to have a center tap diode or transformer. I think we'll be in good shape. So I'll go ahead and end the video here. Just wanted to update y'all that the original plan of just building a regulator circuit into this is not going to work. So we're going to strip this down, make it so we can get some power into this, still get it back over to this plug here so we can make it to the board there and power the oscillator. So I'm going to work on getting this stripped down a little bit, maybe work on kind of lining things out. Hopefully those will fit in the circuit boards. I just got some double-sided circuit board, perf board, that we'll build the circuit onto. See if we can't put something together and get this old oscillator back to working again. So join us in part 3, where we'll be looking more at the turning this into a positive and negative power supply to power the HP 204C oscillator. We'll catch you next time. Just want to give you an update.